Okay, it says Thallium-208 has a half-life of 3.053 minutes. How long will it take for 120 grams to decay to 7.50 grams? Well, this is the half-life formula here. It says N is equal to N naught times 0.5 T divided by capital T, raised to the power of little t divided by capital T. Now, I have here labeled what these mean, and you can see that here. See that here labeled. Let's go ahead and get into the problem. All right, so Thallium-208 has a half-life, so that means my capital T, because capital T stands for half-life. So it has a half-life of 3.053 minutes. Units are not important in this here formula. And now it says, how long will it take for 120 grams? So 120, that meant I start off with 120, so original amount would be this, 120, to decay to 7.50. I'm sorry. It wants that to be left, 7.50. So that'd be N. N is equal to 7.50. Well, let's go ahead and find out. Let me get a different color here. Okay, so let's go. Let's substitute everything in, and then I'll tell you what we're solving for if you don't already see it. So 750 is equal to 120 times 0.5 raised to the little t over 3.053. Well, clearly we don't have t. So we want to find what t is, the little t, okay? So in order to do this, we have to use something called logarithms, because logarithms have a certain property that allows us to take an exponent and write it as a base, okay? We'll talk about that in a second. So we have here 7.50, and then we have, let's not do that, I'm sorry. Let's divide both sides by 120. We can simplify, that'll allow us to simplify this side here a little bit more. And once we do that, we'll do 7.50 divided by 120, and we'll come up with 1/16, which will be 0.0625, which is equal to 0.5. Of course, raised to the t divided by 3.053, because that's what's left over here. Now, after we compute this here, we have this left, right? I'm sorry, my pen is not. Okay, we have this left. So let's go ahead and see what we can do now. The only thing left to do in this here equation is to log both sides, because that's where that property comes that allows me to get that t out of the power, allows me to erase t as an exponent and rewrite it as a base. So I need to get the log of both sides. And if you want, you can go ahead and get your calculators out. Okay, now this is called the power product property. It says that if I have a log raised to, and it's raised to a log of a number raised to a certain power, I can bring that power and rewrite it as a base. So I'll have log, this stays the same, is equal to, now this power becomes a base, so t divided by 3.053 log of 0.5. And that's where that special property comes in at. Now, this is just a regular equation here that we've done in algebra. I can multiply both sides by 0.53, I'm sorry, let me rewrite that here. Let me rewrite that. 0.053. I can multiply it so I can get that out of the denominator. 3.053. And this and that will cancel, and then I'm left with 3.053 times the log of 0.0625, which is equal to t times the log of 0.5. Now I want to get this t alone, so I need to divide by what's keeping t from being alone, which is log of 0.5. So I'll divide by log of 0.5 on both sides. And these here will cancel. I'll be left with t is equal to none other than 3.053 times the log of 0.062625 divided by log of 0.5. And you can use your calculators from here. Let's see, we'll get 3.053 times the log of 0.0625, and then you should get a negative 3.676. Divide that by the log of 0.5, and you will get 12.21 is equal to t. Now, this tells you that it'll take 12.21 minutes in order for this to decay to this. And this is the work here. If you don't have it, you can rewind it and pause the video here or whatever you like.